All right, welcome to our first lesson on probability. It's perhaps our last unit. I'm going to try and squeeze in precision measurement, but if we don't get a chance to do that, then probability will be our last unit. Probability, you've probably seen that word many times in your life, and you have an idea of what it means. And probability relates to the likelihood of something happening. And we can usually reflect the possibility or the probability of something happening with a numerical number. So probability is part of the area of math called statistics, which we just finished. Probability refers to the chance that an event will happen. For example, we see this quite often in Manitoba. We seem to follow the weather very closely. So when the weather person states there's a 30% chance of precipitation, this means there's a 30% chance it'll rain or snow. No, for sure, though, right? Quite often we take this 30% and we kind of file it in the back of our mind. I think it would be more meaningful if there was an 80% chance of snow or rain. Right? For example, if your favorite sports team has an 80% chance of winning, it's very likely they will win, but we don't know for sure. And that's the thing about probability is that we can't say for sure, even if we've done all the math correctly and we have all the past experience and we've studied the data, probability is an area in math that we can't state for certain whether something is going to happen or not. So examine the two statements below. The probability of rain on Monday is 20%. The probability of rain on Tuesday is 90%. Will it rain Monday? Will it rain Tuesday? Will it rain both days? Will it rain either day? The answer, quite seriously, is we don't know for sure. There's a high chance that it will rain on Tuesday than Monday, but we can't say for sure. So there is a greater chance, and that's what probability is, right? It's studying chance. There is a greater chance of rain. Oops, I just ran out of gas again. Chance of rain on Tuesday, but we can't state for sure whether it will rain on either day. We just don't know. Okay, probability is often expressed as a percent, but it can also be expressed as a fraction, a decimal, or in word. That's something to really be aware of. So this is something that I would keep in the back of your brain. A lot of times it's expressed as a percent, especially in weather, right, which we talk about a lot. But it can be expressed as a fraction, a decimal, or in words. All right, complete the following table. The first row has been completed. So part of your job this unit is to be able to move freely between each of these categories, right? Now, I think that you're quite familiar with the fraction form. For example, we just finished a stats unit where one of the lessons might have said Kim got 6 out of 10 on her math quiz. Convert that to percent. So 6 divided by 10, we just times by, that gives me the decimal 0.60. And then timesing by 100 gives me the percent. So that's how this all works, right? Given as a fraction, I have 6 divided by 10, right? 6 divided by 10 equals 0.60. Whatever the decimal is, if I just multiply by 100, that gives me my percent. And then the words are quite obviously just the English words. So let's try working backwards. A percent of 19%. Now remember, this number is, the percent number is always whatever number is given as the percent. This is the, this also means 60 out of 100, right? That's what that means as well. So 19% would mean I get 19 marks out of 100, right? I can take my calculator, because percent's always giving you the marks, kind of converting the test or the score to be a score out of 100. So if I say 60%, that's equivalent to getting 60 out of 100. 19% is the equivalent of getting 19 out of 100. So I can do the division, or I just might know that this is 0.19, right? So then I would say this is 19 out of 100. I guess I should have written everything out, but I don't find this column that important. I think these 3 columns are the important ones. Let's try this one. 35 out of 50. Well, that's easy to convert, right? 35 out of 50. If I do the division, oops, we get 0.7. And if I multiply this, so notice that there are different, 35 out of 50 would be equivalent to 70 out of 100, right? There's equivalent fractions at play here. Well, 50.54, I know that would equate to 54%, so that also would be, it's 54 out of 100. And I could say 54 out of 100. 100. Okay. 1 divided by 8. Now this gives me a decimal number of 0.125. Multiply that by 100, and that gives me 12.5%. 1 out of 8. So it's as simple as that. That's your first lesson, right? Just converting between the 3. Now, hopefully there's a lot that's familiar to you. Just working on percents before, especially in the previous unit that we just completed about statistics. All right, let's flip the page. Example 2. In a science textbook, 23 out of 57 pages contain a picture. Express the probability in the form of a fraction, decimal, percent that a randomly selected page will contain a picture. So when they talk about randomly selected, they're saying if you just took the book and just kind of flipped the pages and just put your finger into one, that's randomly selected, right? What would be the probability you'll get one with a picture? Well, what's the chance that I get one with a picture? As a fraction, it's 23 out of 57. As a decimal, I get a repeat. I get a number that goes on and on and on, right? So I have to round to 2 decimals. So I'm going to say it's 0.40. And then as a percent, now when you're doing your percent, going from decimals to percents, leave your whole percent number in the calculator before you multiply by 100, and then you're going to get a percent of, right? Because we have to be careful about those 2 decimal digits, right? We want to make sure we get the right 2 decimal digits for the percent. Okay. This is interesting. The probability of a certain event is 100%. Like if you know for sure something's going to happen, it's called a certain event. If you know for sure that happen, it's called a certain, event. There's no doubt it will happen. For example, if today is Sunday, then the probability that tomorrow is Monday is 100%. Now, 100% is the percent. This is actually the decimal number. Okay. Also, note, if I did the let's do the fraction. A fraction of 1 out of 1 is the decimal number one, right? That leads to the number of 1. Then when I multiply 1 by 100, it gives me the percent number, 100%. That's how we get this 100% and the 1, right? That's how they're linked. Okay, the probability of an impossible event is 0. For example, if today is Wednesday, then the probability that tomorrow is Friday is 0% or just 0, right? The reason these two numbers stay the same is if I have a decimal number of 0 and multiply that by 100, I'm still going to get 0%. Now, this is something that's going to come in handy for this unit. It's the word complement. So not the compliment when someone compliments you on your new hairstyle, but a compliment refers to the amount of the quantity of the amount that completes something. See that word kind of muddled up in here? It's the quantity of whatever amount you're talking about that completes something, that makes something whole. You can think of it as the part needed to complete the whole. For example, if there is a 20% chance it will rain today, it follows that there is an 80% chance it will not rain. We say that 80% is the complement of 20%. Okay, so it's that leftover piece. Okay, hi, Cynthia. I had problems today too on the internet, so we'll talk to you later. So the complement is the leftover amount that you need to complete something from the given amount. So if you're given 20% probability, the leftover is 80%. I'm going to just put the leftover amount. Okay, determine the complements of the following. All right, so we're just looking for the leftover amount. The percents are probably easier to do, right? Because percents, we kind of already have a bead on what we're doing here. So 15%, the leftover is going to be, well, I just take my 100. Okay, and that was from 100% minus 15% equals 85%. All right, if 4/7 is the complement, well, how many is left over? If I ate 4 out of 7 pieces of the pie, 3 out of 7 are left. Okay, I'm just going to put in brackets here. If I ate 4 out of 7 pieces of cake, 3 pieces are left. Okay, 32 out of 50. All right, well, let's just try this. How many pieces would be left out of the 50? Well, let's just do this 50 minus 32, which is what we did here, right? 7 minus 4 is 3. So I have 18 out of the original 50 are left because 18 and 32 complete the set of 50. Okay, 0.30. Well, let's see. This way I would do it. This is 30%, so it'd be 70%, but they want it as a decimal. So 70% as a decimal is 0.70. What we've done it is, we're not talking in percents here, we're talking in whole numbers. So the highest you can go is 1. 1 take away 0.30 is 0.70. Again, 0.47. All right, let's see what that is. 1 take away 0.47. You could also think of this as 47%, right, if you wanted to. But you're going to get 0.53. You could have thought of this as 43%. 53% would have been the leftover, but they want it written as a decimal. Okay. All right, well, what's the leftover here? Or the original, I guess. If the leftover is 89, how much did you start with? Well, 11%. Okay, so that's the first concepts of probability, what it means, and also the complement. And I'm going to stop there today. I know it's kind of funny that I'm stopping so quickly, but this first part is it's pretty intense, I think, if you haven't done probability before. I'm going to assign a really short, and then we're going to start tomorrow. We're going to talk about theoretical probability. I want to break that up because theoretical and experimental are kind of tough. So I'm going to stop today and I'm going to assign, do assignment 1. So try for homework. I'm going to make it really short today so you can go out and enjoy the sunshine. Assignment 1, number 1. So that's it. I'm just going to stop today and we will reconvene tomorrow.